Yeah, that feature was also hanging actually.
Whatever problem there was, it was affecting also the monitoring system.
Yeah, exactly.
And when you look at the problem was not there, right? It's only
Exactly.
Every time was happening to a bus that you were not monitoring.
Exactly that, yes. As I mentioned, everything was working fine. So that took us maybe 2 minutes to confirm. And as you can imagine, that was definitely an anticlimax.
Pretty disappointing.
And I'm sure some politicians also left their sleep for quite a while because this all happened.
It's actually hard to explain to a politician or the mayor, right? Hey, what was the solution? It's more complex than you think.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nico and Tristan. In today's episode, a prestigious IoT project is plagued by mysterious crashes that leave no trace in the logs and go away when an engineer looks at it.
Hello and welcome to another episode of the Cisco Tech Stories podcast, where we tell outstanding stories from Cisco CX engineers from all around the world. I am Tristan. I am a technical leader in Cisco CX service provider, and today with me is Nico, wireless wizard, Cisco technical leader in wireless world. Hello, Nico.
Hello, Tristan.
And today we have a special guest joining us from the same office as where we are, Jens, a technical leader in IoT and data center. Hello, Jens.
Yeah, hi guys. As Tristan said, I'm currently working in data center, specifically Hyperflex. But as a large part of my career, I was working in IoT, both as a tech engineer and technical leader. And one of the products which were pretty popular, which we supported and were often involved in our cases which we worked on, was an IoT gateway. And as you can guess, today's episode will be mainly about that IoT gateway.
I have a few questions first about IoT, because there's been a lot of buzzwords. There's been Web 2.0, there's been the cloud, and there's been a period where it was IoT all over the place. And when that started, I was like, IoT is just having a fridge that can connect to the internet. You know, what's this going to do about it? So can you tell us basically what kind of technologies, what exact products you were managing as part of the IoT team?
Yeah, indeed. IoT is, probably we're past the stage where it's a bit of a buzzword, but IoT is so broad, it's devices being connected. So your regular PC or network device could also fall under that category. I always saw it as connecting devices which you usually don't expect to be connected, like the fridge you mentioned. But of course, that's consumer space, so not where Cisco's focus is on. We are more in the industrial phase, so connecting devices which you typically or standard wouldn't see connected, like a car, a bus, a machine, a boat, something on the sea, measuring everything you can see. Could be even something like a trash can. That's really projects which we had going. And most of the projects which we had, or the cases, or what customers were using it for, is to get information and optimize the processes they have with that information. So if we take the trash can, for example, instead of having a guy going to each of the trash cans in a city every day to check if they're full or not, you actually measure how full the trash can is and optimize the route for that person to go and check the trash cans.
Okay, so is it correct to say there's two kind of products? There's the gateways, and gateways is a kind of, it's a router that will aggregate multiple type of connectivities, whether it's like Bluetooth, Wi-Fi, cellular, wired, etc. So all the various connectivities that enable IoT, we gather them in one device that we can connect to the rest of the network. And then you also have management tools, right?
Yeah, actually there's three. There is the sensor itself, which collects data. That typically would connect to such a device which you mentioned, like a gateway or a router, something that provides it over usually a certain wireless protocol, and that gateway then has a more reliable connectivity, either cellular, which is more battery hungry, so we can't use it in the sensor, or a wired connection. And then, of course, you have the backends in two sides, one part for management of the devices and those IoT gateways, and a second part where you actually do something with the data, which we almost forget at Cisco because we are there in the infrastructure part. Our job is to deliver that data. What happens with the data, that's more of the customer's concern. But it's an important part.
Okay, but I think typically the sensors were third parties, right? And Cisco was focusing on infrastructure. But that is not true anymore because I think we have now sensors in our Wi-Fi access points, in WebEx devices as well. So we try to use sensors in whatever network device we have closer to the...
Everything can be a sensor. I mean, if you have an access point, you know that your clients are actually your sensors. For example, if you want to do crowd management, by checking how many people are connected to a certain access point, you have an idea of how many people are close to that. Same can be for a cellular tower. So without having specific sensors, you could actually do something with the data. Cisco does have sensors. We have a few solutions where there are, I would say, simple sensor like a water level meter, a pressure meter, a temperature sensor. But I would say in most deployments, customers would use their own either third-party provider or third-party sensor.
How about we dive in? What story do you have for us?
Yeah, so I mentioned those IoT gateways. Just to be clear, that's basically a ruggedized industrial router with a small PoE switch, Wi-Fi access point built in, and often has a cellular backhaul connectivity, GPS, and very important, the ability to run containers on top of it, which, when we'll use another buzzword, we can categorize as edge computing. So on the edge, we already process the data before we send it back. That could be because there is a limited backhaul connection. I mentioned cellular, but in certain cases it was satellite as well. So it's important to aggregate the data and filter the data on the edge already before sending it through. So these IoT gateways are pretty mature, and the story which I want to tell, they were already pretty mature already. The specific devices are end of life at this point, but there is a successor working in a very similar way. So for this customer, these devices would be installed on a bus. The device would provide Wi-Fi to the passengers and using its backhaul cellular connection to provide that internet connection. And a secondary feature, they would display route info. So there was a small display on the bus, also processed on that device itself with that edge compute. That would mean that even if briefly that device loses connectivity, we can still display information and have things operational.
So the screen don't go dark as soon as you go under a tunnel, basically. That's what it
is. Exactly. And there was also a part to track actually what the bus driver was doing. So not only to know where he was, but I believe it was connected to the CAN bus of the bus. So you could see how is this bus driver doing in terms of acceleration. The device also has an accelerometer, so they could even see how wild or how calm the bus driver was doing. And I don't know about the specifics about that, but I can imagine they kind of made like a scoreboard of who is the best bus driver, who is the most fuel economic one, who is treating his passengers in the most comfortable way.
Sleep detection maybe as well?
Sorry?
Sleep detection, if the bus driver sleeps.
I don't know. I don't know if it goes that far, but that could be an option, yeah. So, yeah, this customer, obviously this is on a bus. It's not critical. It's not like the bus will stop or even explode if the device doesn't work. But after an extensive proof of concept, so they did a lot of testing. They did a big proof of concept with a few buses. Finally, the customer decided to give it a go. And the project started, and they had a rollout where they deployed a few hundreds of these devices to buses all over the country. So that means the buses are taken in to the depot, they install the device, they do a test run, the bus is brought back the bus is brought back in service, and they can start using the solution. So everything went fine. The rollout went as expected, or even better than expected. They were ahead of schedule. There was some problems with ignition management.
One question about that. I guess that's maybe one of the reasons why you cannot use a regular router, right? So first, it has to be ruggedized because there's a lot of shock probably in the bus. But then what is different about those industrial routers compared to a regular one?
Yeah, exactly. Ruggedized is one thing, but also what people typically would forget easier is that it has to be able to withstand extreme temperatures. In the bus, if it's outside in winter, if it's minus 20 outside, it actually also has to work. But also, for example, the bus was staying there for the night, then the air conditioning is turned on, and in like a matter of minutes, it becomes from minus 20 to plus 20 degrees Celsius. So, and of course, in the summer, if the bus is staying there in the sun, it can easily get up to 70 degrees Celsius or higher.
A stupid question. Is the router inside or outside of the bus?
It's inside the bus.
Okay.
Fortunately, yeah.
But it still can get cold when it's at night, right? And the bus.
Yeah. If the bus is in the depot, it's not. I mean, it could be even outside staying for the night, so it's not heated or anything. So, and also, I mean, when you have those temperature differences, you have a problem with humidity and condensation. So that device obviously has to be able to withstand it as well. But about the ignition management, since the buses started and stopped quite often, it is connected. It could be connected to the battery, but you don't want this device to actually drain the battery. So it would, in a lot of cases, it would be stopped and started together with the bus. And you want to do this in a graceful way. So if you shut down the device multiple times over a short period, if you would take a standard router, there is a chance for file system corruption and the device not starting anymore. With proper ignition management, you take care of that and make sure the device survives all of this.
Right, because we're talking about a lot of start and stop during the day, right? While a regular router is just when you have a power failure or like a couple times a year, and here it's going to be a couple times a day.
Yeah, exactly. I mean, a regular router is robust enough to take this a few times, but it's probably not tested and made to have this multiple times in a day as an expected scenario. So yeah, these problems were resolved pretty quickly. It was mainly a configuration issue. We found a minor defect, which the business unit actually solved pretty quickly. We had an engineering release tested. We were good to go. So everyone was pretty happy, actually. But after a while of having these running in the field, from time to time, devices would stop responding completely on application side. Initially, we didn't get any reports from that because the customer thought, oh, that's weird. Let's restart the device. Everything goes fine again. We're good.
Wait, I have a question on the application. Where was the application running? You said it's running on the router itself, right?
Yeah. So the router itself actually has a hypervisor on top, and Cisco iOS runs on top of that hypervisor, but there is space for another virtual machine, which then hosts containers. In this series of routers, and Cisco has different names for it depending on which vertical you're in a bit, but in this case, it's called IOX. So that's basically the ability to run a Docker container on that device itself. Of course, you're restricted with resources, but for the use case we had here, this was a perfect match. So, and that was exactly what stopped responding. That container stopped responding completely.
So it's not necessarily the application itself, but the container was unresponsive.
I mean, at that time, we were not sure. It could be the application. It could be the complete container. It could be a part in the hypervisor. We didn't know. So, but after some time, the customer started to report that because it happened more and more, and they noticed a correlation. The longer the device is up, the more chance we have that this problem actually occurs. So just to be clear, with the ignition management, it didn't happen all the time that the devices were restarted every time because we monitored the battery. If there is a weak battery, it could be that the device actually does stop and start with the bus to not drain it further. If there is a good battery, the router will actually stay up and running until the next time the bus is started. Also, depending on how frequent the bus is used, how long it's staying idle during the day.
So that means there's legitimate reasons for the application to stop responding, right? Like if the bus is in a tunnel, it will not respond, but that should be a short amount of time. But you said also if the bus is stopped for a while and the battery is not that good, it's also expected that it won't reply, right?
Yeah, but then when they would restart, I mean, if the battery goes down enough, they would restart the bus that's actually like a reboot of the router, the application would always work. It's only during long times of operation where actually the router didn't receive a restart, we could see these outages.
So it's literally when the uptime of the router is long, right?
Yeah, yeah.
And it would not resume working, right? It would stop and not work anymore further from there.
Yeah, exactly. Yeah, so rebooting that device, in the case the battery was still fine and would not actually trigger ignition management, would involve a physical action in the field. That means that, from a customer standpoint, it's a costly operation. They have to send an operator somewhere in the field. Not all of their depots have people that were skilled to do this. So they had to send someone out, travel there to actually pull the plug, put the plug back, and the device would reboot. So, of course, you can feel that they're not so happy about that. And part of the reason is that the customer used some of our tools to manage these devices, but not up to a level where they could control things like this, like doing a reboot. We did support that, but they had their own remote connectivity solution, which was also running in the same single stack application, which was hanging at that time. So they did have the ability to monitor the devices and to reboot them, but that feature was also hanging actually.
Whatever problem there was, it was affecting also the monitoring system.
Yeah, exactly. So they had like a single container which had all features. So that's microservices just because you want to call it microservices, right?
I can see a design problem there.
Yeah. So as Stack, of course, we need to solve this. And together with the customer, we did extensive troubleshooting. There were no clues in the logs. That's always fun if you need to troubleshoot something. We did set up some scripts to remotely log in and to log all the output before the container stopped responding. We increased the logging level to monitor the application and the underlying container runtime and the hypervisor as well. But strangely enough...
But what were you checking in the logs? Because if I'm not mistaken, you have logs when it's working, but then when it's not working, you cannot go and collect the logs, right? So how do you do that?
Well, there is persistent storage on the device and flash, and we were saving logs there. We were monitoring everything. There are standard system logs, so you can check in iOS, you can check on the actual virtual machine that's hosting that application framework, but we never found anything obvious. You can increase the log level there. We did that. The customer said they did the same on application level and saved it on the persistent drive. But the strange thing is that on all the devices where we increased logging, we were never able to catch the problem. They just kept working after we increased logging. And on top of that, the issue was not that common. So we had to be lucky to catch an occurrence of it.
It's always like that. That's always the thing. And when you look at the problem was not there, right? It's only...
Exactly.
Every time was happening to a bus that you were not monitoring.
Exactly that, yes. And of course, when we had a device which had the problem, there was always a healthy pressure to bring the bus back in service as soon as possible.
Yeah, you cannot take it out of service just to monitor.
Because the bus out of service costs money.
Yeah. Right. That's something we always like, as tech engineers, we always like to do is like, can you, for sure you have a quick fix to bring everything back up, but can you keep one device, one thing broken so that we can look at it, involve developers and really take our time? But that was not possible.
Right? So exactly. Okay. So, and we had to deal with the difficulty connecting to the devices because they were on actively driving buses. And although typically you have a proper cellular connectivity, there are still areas where it's a bit slower, where you have a short disconnection, and that ability to remote dial in was not that robust. So it would often be in the middle of a troubleshooting session. You're up to something, but it gets disconnected. You have to restart again.
It looks like you are playing a game, but in hard mode.
Yes. It felt that way, yes. So we had the facts all lined up. So some devices were showing this behavior after a few hours. Some devices were showing this behavior after a few hours. Others, it took a lot longer, and some of them even never got stuck. Obviously, we did try to swap devices. We RMA'd some of the devices. The customer had people sent out to the country even to reboot devices and be on standby so they could be there immediately when there would be a hang of the application.
And it looks like something that was taking a lot of time, right? Because you mentioned putting people on standby and things like that. That's not something you do.
Yeah.
overnight.
No, it took a while, especially because the issue didn't appear a lot. We were not able to reproduce it manually, so we had actually no clue about the root cause.
What was the overall times? The time this took from the early deployment to.
I think the stage we're in now that we're talking about now was easily 6 months after they started to report the problems.
Okay, so a lot of pressure to get it solved, right? Because that's 6 months of pain from the customer.
Yeah, and they already had the problems before they started to report them, as I mentioned it. So on customer side, things were heated up already. So we were a bit desperate, right? We were not able to reproduce this in the lab. The customer was not able to reproduce this in their testing environment. And everything we did to get meaningful logging resulted in the issue magically disappearing. And on top of that, this issue was pretty visual in the country, but also to the public, because this was announced as a new prestigious digitalization project. It was all over the news. The mayor was there with the buses and the display. And then after a few days, people started to post pictures with blank displays or error messages. So
it's a very bad look.
Yeah. So random blank displays in buses, the bus losing track of where it is, no driver statistics, things like that.
I want to sidetrack for a minute. You mentioned the customer test bed. They had a test bus or just like the same setup but in the lab?
They had multiple buses driving around where they had the solution installed, but on routes where they could easily take the bus out. So there was redundancy. They had additional buses, so they could, let's say the bus does its track, and then the next day the bus stays in. For those buses, it was not a problem. For the regular schedule, taking a bus out causes actually a problem in the schedule, so that's usually not an option. There were, of course, on a political level, this got heated as well because it was so visible. There were discussions and pressure from bringing all buses back in to actually remove the hardware, stop the project at all, do planned reboots every day, or completely kill the project. Again, we were clueless and decided to reconfigure some vehicles to have a permanent VPN connection on iOS level. So that IoT gateway still runs Cisco iOS. There is an ability to have VPN, but the customer decided to use their own remote connectivity solution running in that same container, which obviously wasn't really helpful.
The target was what? To be able to connect to the router when the container was stuck and try to figure out why it's stuck there.
That would allow us to actually, two things. We could monitor the device constantly without the need to actually dial in. The connection could drop sometimes because if we had poor coverage, but usually that type of VPN connection is a bit more robust. And also, second part, like you mentioned, that would give us the ability to actually dial in even if that application completely hangs, even if that container completely is stopped, so we could see what was going on. So for convenience, we picked up devices which were geographically close to the head office, located in the capital, because these would have a better coverage and it would give us a more stable VPN connection, of course. And of course, if we would need physical access, it would also be easier to dispatch people because they're nearby. So after some time, we were lucky. We were lucky enough to have access to a bus where the application stopped working, but the VPN to the IoT gateway was available. So we carefully checked the state of the device, and everything turned out green. Exactly as we could see in our other management tools or other monitoring which we set up, nothing strange in the logs. We connected to the console of the application and everything was just working. The device was responding. Maybe we connected to the wrong device. Maybe the app wasn't stuck. Maybe it was something else this time, maybe connectivity. But again, nothing special in the logs. And as I mentioned, everything was working fine. So that took us maybe 2 minutes to confirm. And as you can imagine, that was definitely an anticlimax.
Pretty disappointing, indeed.
Yeah.
But what does that mean? Because you connect to the console of the application and it shows that it's still running. but you still cannot get the data remotely?
We were getting the data in remotely. So we thought the application hang, that we were hitting one of those occurrences. But when we checked, everything was green. We checked with the customer and they said, no, data is coming in just fine for this device. So we were back to the beginning.
It was a false positive, right?
Yeah, that's what we thought. So a few days later, the same bus again reported in a hung state. Same scenario when we connected to the device. Everything looked perfect again, but this time we triple checked before doing any troubleshooting, and we were sure that the application was not responding before we started troubleshooting. Again, the application was just acting as nothing happened at all as soon as we were accessing the console. Nothing special in the logs, exactly the same error message on the console in the local language, which we saw on working devices and in our test environment as well. So we started a discussion with the application developer, which was third party and didn't make things easier. Their English was not the best, and we had to communicate through the actual customer, our point of contact, with them. We asked them what the messages on the console means. Nothing strange. It was just an indication that connectivity got lost temporarily, but nothing to worry about because the next message said it just resumed as expected. And this is totally normal because, as I mentioned, we can't have 100% coverage all the time. But then one of the developers mentioned, I don't remember if it's an email or over chat or on a WebEx, they said, we have tons of logs indicating the same behavior in the debug files on our test environment, and yet everything is rock solid, so this can never be the issue. So you guys are logging different in test? Yeah, we have debugging enabled to log on disk, but as a Cisco best practice, we were told that this is not to be used for production as it can wear out the flash-based storage on the device. Right?
And that's something I heard in other products as well. If you have way too much logging and the device has an embedded flash and it writes all the time on it, iOS is trying to spread out the load on the whole flash, but if you have enough write cycles, you're going to kill the flash, right?
Yeah, exactly.
It can happen quick.
It can sustain normal logging, let's say, what you would expect from a router or a few entries from the application, but our best practice is to not write to those logs exactly for that reason, because you would eventually wear out the flash, especially if you write tons of data all the time.
And this is just valid for any device that has a flash memory, right? Not just Cisco device.
Exactly, yeah.
For a computer, it's the same, anything that has a memory, flash memory.
Mm-hmm. So they were absolutely right. I mean, in tests, they were writing to flash because obviously they wanted to keep track of everything that happened, and it's a risk you take for a device which you're testing with.
So if I understand correctly, they said in their debugs in the lab, they were seeing the same lost connectivity, resumed connectivity, lost connectivity, and that was not a problem to them.
Exactly.
But you kind of triggered on the fact that they had debugs enabled all the time,
well,
right?
that was a different... In the test scenario, which they run also for months, they never, ever had that issue. I think we asked that 300 times to the customer, and every time, up to the point they even got angry when we dared to ask the question, they said, no, and test, this never happened. So the only difference at that point between production and test is the way they were doing logging. So probably that's somewhere... Probably that's the direction we have to look into, right?
Because you said, when we look at the problem, it doesn't show up, right? And that kind of started to trigger me, like, this is going to be the root cause, maybe.
Yeah. So indeed, the pieces started to come together, and we asked, can we enable debugging on the worst performing devices which had the most hangs reported so far, just for a few days? So, I mean, we might trigger flash wear out, but at that point, honestly, we didn't care much. We just really
we can replace that device.
Yeah, we wanted to find the root cause. And exactly, no more outages on the devices which had debug logging enabled. We were getting close, right?
Enabling debugs solves it.
Yes,
it's close, right?
Yeah. We could say that, but we wanted to find the obvious root cause.
People are usually worried that when you enable debug, it's going to impact performance. Here you were enhancing performance by enabling debugs.
Yeah, those are special debugs. So yeah, like I said, what was different in production, the logs were not being written to a file on the integrated flash storage, which we indeed advise against, but just to the console. And here we need some technical background, I would say. So on a regular bare metal Linux machine, when you write to that console, it appears on the physical screen. And if no one is there to read the text, it eventually just scrolls off the screen and it's lost. That's fine for the kind of logs which that customer had. In that scenario, there is no limit on how much text can be sent to the console. You can basically spam that completely. Nothing will happen, maybe a bit of performance impact. In a container, we don't have that real console. Instead, there is a pseudo console with a buffer, and that one has a size limit. So when that buffer fills up, a new write to the console from a process will block the process until the buffer is cleared by logging into it. Now, this problem does exist for other container types as well. So not only for the container runtime we were using on that IoT gateway, but it's not so common for people to run into it, as I believe the default size for Docker or LXC is around 100 megabyte, and that's a lot of text. And there are also some options to have this in a non-blocking way, where basically when the buffer is full, it removes the oldest message. On the runtime we had on the IoT gateway, which was LXC based at the time, now it's Docker for most of the platforms we have, we were pretty resource constrained. So the size was set to 256K. In practice, this came down to around 5,000-6,000 lines of logging before the application would hang.
Yeah, it's not so much, huh?
No, it's not so much. And they were pretty verbose. So the customer would not just log that it disconnected. It would put a lot of other information in that log as well. They were just assuming it's on the console, it doesn't hurt. If we ever need it, we can use that information to troubleshoot further. So since these log entries to the console were seen more frequently in worse networking conditions, remember, they were logging disconnects and reconnects. This explained why we saw this more frequent on certain locations without a clear pattern.
So the buses that were not reporting any issue were the easy routes where there was good coverage and very few.
Exactly.
Okay.
And that also, at that moment, we also realized we made it more difficult for ourselves. Remember, we chose those devices close to the head office in the capital, where there is pretty good cellular coverage to actually monitor closely, to have that permanent VPN connection. But these were almost never logging any disconnects and reconnects. So if you would have picked the worst devices, with a chance that it would be hard to troubleshoot, we would have a way more occurrences of the issue.
So if I understand correctly, the fact you were monitoring the logs was making the issue go away because the buffer was not getting full, right? So was the solution to enable debugs everywhere and monitor constantly all the devices, or how can you properly solve this? You have to empty the buffer, or?
You're completely correct. So that's exactly why when we started to troubleshoot the issue, and especially those few times where we hit the issue and had a proper VPN connection, as soon as we started to look at the console, the problem disappeared straight away. That's why that first occurrence where we thought that we had a false positive actually was that issue, but we fixed the issue by looking at the console.
It was not a false positive after all.
No. And we took several actions to remediate on this. So initially we started by documenting this explicitly and by providing first a bit of a dirty workaround, which just has a process running. I believe it was even a cron job that just flushes the console every now and then before it fills up. But the main fix of the problem was just to comment out that simple print statement in the application script, which the developer had there for debugging purposes.
So their application will stop logging, I lost connectivity, now I got connectivity back.
Yeah,
and
exactly.
then you will typically never fill those 5,000 lines of logs anymore.
Exactly, especially after the developer confirmed that they never care about the message. It's just there as expected. No one would ever use that to further troubleshoot. And even in the event they would need it, they could enable debugging later anyway. So I'm not sure how that developer could explain up the chain how that single £sign to comment out that print statement was keeping up a lot of people at night, not only in Cisco, but also at the customer. And I'm sure some politicians also left their sleep for quite a while because this all happened.
It's actually hard to explain to a politician or the mayor, right? Hey, what was the solution? It's more complex than you think, but also quite simple in the end.
It's a very complex piece of code, but we had to comment out one line of text.
But that's the thing, right? You would have never thought about that without all the analysis that was done before. So even if the fix was very simple, everything else to reach that point was very complex and required a lot of...
Yeah, and I mean, I left out a lot of details, but initially you suspect everything, right? So you start to troubleshoot networking, the configuration, you do I mean, some performance testing, maybe some other, I mean...
You literally left out a month of details, right? You said it.
Yeah. I mean, it's not like... it's easy to tell the story when you know what was the root cause, but at a certain moment, especially after a longer time, if you don't have a root cause, you start to be very creative of finding possible suspects of things that could cause this problem. So yeah, I think that was one of the best checked and monitored environment which we had.
I think it's the most difficult type of cases when you collect the typical logs and there's nothing special in the logs. So if you just believe the logs, everything is working, but obviously you know that not everything is working. So you have to start to be creative. Like, what could go wrong that maybe does not show up in the logs?
Yeah, and it's that IoT gateway is not an easy device because you have that lower level hypervisor, which is proprietary. You have Cisco iOS, which plays a big role, and you have then another Linux VM, which is running a modified version of a container runtime, LXC in that case. So, and in all of these cases, we are restricted in resources, so things are optimized to a way that logging can be maybe not so important anymore, because otherwise you would run into resource limits. So you don't always have full logs, you don't always have troubleshooting tools, so it doesn't make it easier, of course.
Actually, that talks a lot to a typical problem we have. Is this felt like the Schrodinger's problem, right? If you look at the problem is not there. If you stop looking at it, the problem is there. We have varying types of similar problems when enabling debugs, right? Some device, if you enable debugs, you increase the CPU usage and you can create more problems. I remember a specific use case where when we enabled debugs, the problem was even worse, but it was not the problem we were troubleshooting that was worse. It was just the CPU being high and the device starting to struggle. So the debugs have varying impact, right? Here, they were having a positive impact, which is quite funny.
It's the first time I hear that.
Yeah. So that, I mean, you can pull out a lot of conclusions from this. Like, enabling debugs, you need to understand first what the debugs tell you, because here debugs were telling you everything is fine, but obviously it's not fine, right? So the debugs tell you one aspect of the problem. And second, the fact you enable debugs also change the observation condition of the problem, right? You're changing the environment.
Yeah, I think part of the problem was that everything was actually handled by the same container. So if that container stops doing anything, it also stops logging everything. And yeah, from our side as well, as I mentioned, because of those resource constraints, we were not doing a lot of verbose logging. So I believe that on a regular container with a regular, not so trimmed down Linux distribution running on top of it, there will be a warning message eventually in your syslog or kernel log that warns you that the buffer is about to fill up. We got rid of those warning messages because we don't have space for logging anyway. Right. So that made things quite a bit harder.
And also, I think it speaks volume on the difficulty. I mean, when you have network issues in a enterprise network, it's already hard. But then the more physical and out in the wild, I would say, you get, the harder it is, right? So in Wi-Fi, I always complain that issues are harder to troubleshoot because you have third-party devices, you have a physicality to it. But in terms of WAN, like IoT or citywide issues, like having to call back a bus is
Yeah, exactly. And you know, I mean, especially if you're a few months in to such a case, you know that if you ask, can you please go and check the bus physically, it will not be well received because they think, again, do you know how much that costs? Exactly. Do you know how much time that takes? Do you know what impact this has? Not only in terms of I mean, money-wise, but also in visibility. Like, again, a bus not doing its route, that's a great project.
And you cannot put console everywhere, right? Because, I mean, in one studies, I have the issue where people sometimes have access points in the city on a pole 5 meters high. And they say, I cannot go plug a console there. It's not as easy as you think.
Yeah.
And here, kind of the same, right? So you had a console, but that was part of the problem. It was not a real console.
Yeah. Well, yeah, another problem was that our remote access was not robust. We didn't have the proper access, and it was also in that same single application. So that was probably a design failure, a design flaw.
Right. But to be honest, remote monitoring was part of the plan, right? So they're
they thought it well through. Maybe,
but there's a learning on how to make it more robust.
Yeah, exactly.
Yeah. Okay. Yeah, but I think having the maximum possible remote monitoring or debugging when you have such an environment is key, because even if that costs you a little bit more in the planning phase, the money you save in troubleshooting, because any random issue might pop up. But if you have zero troubleshooting capability, you're going to have costs afterwards that you didn't plan.
It's always a bit of a trade-off between how much do we spend for just in case, almost like an insurance, which you take just in case we have to troubleshoot remotely. And then it's a trade-off between, do we actually send someone in the field, or do we invest more in advance to prevent having to send someone in the field?
But like you said, it's an insurance, and you don't really want to put the cost up front sometimes, right? But after the problem happened, you realize that it was something you should have invested a bit more in, and take that as a lesson learned for the future. I guess now they probably have a better logging mechanism. Probably know.
Yeah. Right now, for sure, there are a few new products. So right now, we do have a solution for that. We actually had it back then as well, but it was a costly one. But right now, we have an IoT operations dashboard, which takes care of exactly that. It has the ability to open up a VPN on iOS level on demand, so it doesn't have to be open all the time, without having a dependency on the actual application container running. So that would have been a solution. The solution we had back then was not so elegant, but it was there. The customer decided to not use it, and I think that actually costed them much more than picking the solution.
It's funny. I remember you made a comment that when the device loses connectivity, nothing too bad happens. The bus doesn't explode. It reminds me of a given movie where if they slow down, the bus would explode.
Oh, yeah.
It would have been funny. Like if you lose the 4G
IoT
connection.
right there, before the buzzword was popular.
So if I understood you well, in order never to face the problem, they should have stayed in the city and never shut down the engine. So keep driving in circle without leaving the city center, right?
Make sure you never lose connectivity to your cellular network.
Pretty cool.
Okay, I maybe have one last closing question I wanted to ask you. We talked about cellular here. The uplink for the router was cellular. There's another popular protocol in IoT, which is LoRa, right? LoRaWAN. I never know which one of the two it is. LoRa. Some people say LoRa, LoRaWAN. Can you tell us a bit more about that? Why couldn't we use LoRa here for the router, for example?
To answer your question, I'll go back to what I said a few sentences ago. It's always a trade-off. And if you talk about wireless communication, there is always a trade-off between speed, range, and power usage. And LoRa actually takes a trade-off very hard on speed. So it's pretty slow, but it has a nice range and very low power usage. It's also called LPWA, so low power wide area network. To give you an idea about how low the speed is, we talk about messages per day. So we don't talk about kilobytes per second. We don't talk about kilobits per second. We don't even talk about bits per second. We talk about messages per day. So in this case, LoRa would not be a suitable solution, right. But for a lot of other ones, it could be. It means that because it's so low power hungry, you could manage 5 even to 10 years on 2 AA batteries. For a solution, for example, that sends a few messages a day, that's a good solution. Think about a parking sensor. So instead of wiring your whole parking lot, you just drill a hole in the ground, put the sensor there, and after 5 or 10 years, you have to replace the batteries.
So, for example, for the trash cans you mentioned when we started, that would be perfect, right?
Yes.
Twice a day you can report the trash can usage, and it's good enough.
Yeah, there is no use in seeing all the time what's the evolution of the trash can filling up if you only go pick up the trash maximum 1 time a day. So you only need that information, let's say an hour before the route is planned to do the pickup.
So here the huge blocker was that there was guest Wi-Fi in the bus, right?
Exactly.
Way too much throughput for LoRa. But then it also depends if you say we just want the bus telemetry. Typically a bus telemetry, you would want it kind of near real time, right? You would want to see the actual activity of the bus, at least every few seconds. some small report. So that's still way too many messages for LoRa.
It works in theory, but you can feel that the protocol is not designed for that. It would work in theory. There is also a limit on how much of a bandwidth you can use or how much airtime you can use. The standard actually defines that you need to keep the air free for a certain time after sending the message in order to not fill up that frequency in the air, actually. So that would limit you in how frequent you can send messages as well.
And because you probably have a lot of buses, it's probably better to have cellular because
also
there's a lot more throughput.
Another important thing is that LoRa operates in unlicensed spectrum. So anybody is free to use that frequency range, while cellular is regulated. So there is a lot less chance to have something there actually disturbing the signal.
Okay, very nice. And is LoRa made to be static, or can you roam around? Because here the buses actually drive quite fast.
You can roam around. It even has a method of doing geolocalization. So if you have 3 or more base stations, LoRa base stations, which receive your message, you can actually pinpoint the location of a device. So it's definitely it's made with that in mind for devices that are moving around.
Nice, super cool.
Yeah, didn't know about that.
Okay, well, that's it. We don't want to waste too much of your time, so thank you for coming.
Yeah, thanks again. This was great.
Indeed. Thank you, Jens. Bye. Thanks for listening to this episode of Cisco Tech Stories podcast. We'd love to hear your feedback, so reach out to us on Twitter at Cisco Tech Stories. Our music is produced by our multi-talented Chris van der Kruis.
Next time on Cisco Tech Stories.
We're going to solve this. So we sent 4 new CPUs on site, and it actually completely works. So I was sitting there, I saw the field engineer coming, I saw the part coming, and I saw the field engineer not going to the data center, but he went to another room, a separate room. So I think all parties in the end were very happy, but we could have only fixed it by going on site.